Hey guys, welcome back to the LearnAPChem series here at LearnAP. In this video, we're going to talk about limiting reactants, percent yield, and titrations. So we'll go over what is a limiting reactant, how to find a limiting reactant, theoretical yield and percent yield, and titrations. As usual, if you have questions, leave a comment, or you can ask in the weekly live streams we do every Sunday from 5 to 6 p.m. Eastern. Other than that, we'll get started. Alright, so let's start by talking about limiting reactants. And so you might be wondering, well, what is a limiting reactant? When you have a chemical reaction, the amount of a certain element or compound that is completely consumed in the reaction is the limiting reactant. And so a limiting reactant is going to limit how much of the reactants will become products. So that was sort of a wordy definition. Here's a real-world example of a limiting reactant. If we have this equation, methane combining with oxygen to produce water and carbon dioxide, let's say we have 10,000 moles of oxygen, but only 1 mole of methane. That 1 mole of methane is going to be completely consumed, and so that's the limiting reactant. And that is going to limit how much of this oxygen will become products. Not all 10,000 moles of oxygen are going to combust because CH4 is our limiting reactant. Okay, so in the last example, it was pretty obvious what our limiting reactant was. But a lot of times it's not so obvious. So how do we determine the limiting reactant? Well, first we're going to want to pretend that each of our reactants reacts 100% to form one of the products. So taking this example right here, I have methane combining with oxygen, or combusting, to produce water and carbon dioxide. So here, I'm going to pretend that each of my reactants react 100% to form one of the products. And you just pick one. I'll pick carbon dioxide. And so I would take my grams of CH4 and grams of O2 and convert that into moles of carbon dioxide. And now whichever reactant forms the least amount of one of the products when reacted is the limiting reactant. Let's take a look at what this looks like. So again, I'm going to pretend that each of my reactants react 100%. So here I have 32.36 grams of CH4. I need to convert that to moles of carbon dioxide because I've picked that as my product. So my molar mass for CH4 is 16.04 grams per mole. And then here, convert this to moles of carbon dioxide. And I in fact see that this comes out to 2.01712 moles CO2. And here, I'll do the same for oxygen, so I have 63.78 grams of O2. And now I'm pretending if all of this reacts, how much carbon dioxide is going to be produced. So my molar mass here is 32 grams per mole. And I have 2 moles of oxygen for every 1 mole of CH4, of CO2. And this would react to give me 0.997 moles of CO2. And so now I'm going to look at which reactant forms the least amount of products, which in this case is oxygen. So here oxygen is our limiting reactant. Alright, so now let's talk about theoretical yield and percent yield. So theoretical yield describes the amount of products that will be made if all of our limiting reactant reacts. However, in the real world, this almost never happens. And so a better estimate is what's called percent yield. And percent yield describes the percent that actually reacted. So our percent yield is equal to our actual yield over our theoretical yield times 100. And percent yield is just describing what percent of our reactants have actually reacted. Alright, so let's do a quick example problem. So 6.21 grams of HCl and 4.94 grams of NaOH react, and 2 grams of water are formed. What is the percent yield of this reaction? So pause your video, unpause when you think you've got the answer. Okay, so what you should have gotten is that 89.9% is our percent yield. So if you got this, feel free to skip forward. Otherwise, continue to watch and hopefully I can clear up any confusion. So first of all, we need to determine our limiting reactant. So to do that, we're actually going to have to write our chemical equation. So HCl plus NaOH yields H2O plus NaCl. And this is balanced, so we don't have to do any more work there. So next, let's take our HCl and pretend that that reacts 100% to form whatever moles of water. So we'll do that. Our molar mass of HCl is 36.46. And then we have 1 mole of HCl per 1 mole of water. And here we're going to end up with 0.170 moles of H2O. Now let's pretend that 100% of our sodium hydroxide reacts. And then our molar mass here is 40 grams per mole. And here, 1 mole of NaOH and 1 mole of water. And this is going to get us 0.124 moles of water. So here we can see that NaOH is our limiting reactant. So next, let's see what our percent yield is. So I'm going to convert this 2 grams of water into moles. So I believe I had 2, right? Okay, so 2 grams of H2O. And our molar mass is 18.01. And this is going to get me 0.111 moles of H2O. And this is our actual yield. Here's our theoretical yield. And so I'll just plug this into my percent yield formula. And this is going to get us 89.9% yield. Alright, so now let's talk about titrations. A titration describes the amount of an acid or base to completely neutralize another acid or base. There's also oxidation reduction titrations, but for right now we're going to focus on acid and base titrations. So an example here would be the problem we just did, where we have an acid and a base neutralizing each other. Now in a titration problem, you want to make both the acid and the base the limiting reactant so that both are completely used in this neutralization reaction. So a titration problem is just a special type of limiting reactant problem. Alright, so that brings me to today's challenge problem. How many grams of NaOH is required to titrate 8.32 grams of H2SO4? The solution to this problem is on our website, learn-ap.com, and I'll also put a direct link in the description. Guys, if you found this video helpful, please like and be sure to subscribe to our channel for future content. You can like us on Facebook and follow us on Twitter so that you can be updated about our weekly live streams, which we do every Sunday, where we answer your questions about AP Chem, and those are from 5 to 6 p.m. Eastern every Sunday. Links for that stuff will also be in the description. Leave a comment if you're still confused about anything, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I'll see you in the next video.